All right, guys, welcome back. So in this video, we're going to talk about integration by inverse trig. And then the second part of this is going to be trying to answer this question. Like, we can integrate fractions that look like this. So say you have, like x plus 5 over x squared minus 3x minus 4. Or we can integrate 1 over x squared minus 4. And we can do those by using the strategy of partial fractions, which we learned about last week. But the question that you're probably asking yourself is, what if the bottom cannot be factored? How can we solve it in that situation? So what if we're not able to factor out the bottom to use partial fractions? And that's what the strategy is going to talk about today. So for our first example, let's suppose I ask you to integrate something straightforward, so say 1 over x squared plus 1 dx. Now, before we take a look at this, let's go back to some things from first semester that you probably forgot. If you have the function inverse tangent of x, the derivative of that was 1 over 1 plus x squared. If you had the function inverse sine of x, also known as arcsine of x, the derivative of that was 1 over square root 1 minus x squared. And if you had the function inverse cosine of x, the derivative of that was the same as sine, it was just negative. So what that means is if we take the derivative of inverse tangent and we get 1 over 1 plus x squared, when we go backwards with integrals, that's what we're going to get. So if you have to integrate 1 over x squared plus 1, you're like, oh, that's just this. So the integral 1 over x squared plus 1 is just the inverse tangent of x plus c. It's just going backwards by the inverse trig derivatives that we learned about 5 months ago. Okay, now, the next thought that you have is, okay, well, what if it's not a 1? What if we have the integral of 1 over x squared plus 25? Well, how can we look at this? If this were a 1, I put a dx, if this were a 1, we'd be good. So what we're going to do is we're going to actually make it a 1. So we're going to make it a 1 by factoring out 25 on the bottom. So I'm just going to try and simplify this. So I'm going to say 1 over x squared plus 25 is equal to, okay, so on the bottom, I'm going to factor out a 25. So then what do I have? Well, I have 25. Okay, well, I can't really factor out 25 from an x squared. That's like getting blood from a stone. But I could write it as x squared divided by 25. Because let's see, does that make sense, right? If we multiply 25 by x squared over 25, yeah, that does give us x squared. Great. So that's what I can do. So I can rewrite this integral. So I just took this, I kind of factored out this constant from the bottom. So I'm going to rewrite the integral as 1 over 25 times x squared over 25 plus 1 dx. Okay, and now we can pull the constant out in front. All right, that's a strategy we've done a million times on an integral. So we can go ahead and just write this as 1/25 times integral of 1 over x squared over 25 plus 1. Okay, now here's a little trick. We want to be able to write this as like kind of as like something squared. So it's like instead of being like something squared plus or something over something plus 1, we want to be able to put it in the form like something squared plus 1. So what we're going to do is we're going to then write the x squared over 25 as x over 5 squared. Just kind of take the square root of both of them. I'm doing this because my goal is to get it in the form of an inverse tangent, to get it into a 1 plus u squared so I can do the inverse tangent. So I'm going to turn this into 1/25 times integral 1 over x over 5 squared plus 1 dx. Okay. Now from here, what we're going to do is a u sub. So we're going to do a u sub with this part that's in parentheses. So we're going to pick u to be x over 5, or 1/5 x, of course. So the derivative of that is just 1/5 times dx. Okay, so let's help ourselves out. We put a 1/5 here, we balance with the 5 in front. Okay, so when I do that, in front, the 1/25 and the 5 is going to balance to be 1 over 5 times the integral here. So we have a 1 over u squared plus 1, and then this just becomes a du. Okay, and then we're chilling. So this is just 1/5 times inverse tangent of u plus c. And then we'll just replace that. So that's 1/5 times inverse tangent of x over 5 plus c. All right, let me give you one to try that's pretty similar to this, and then we'll be able to kind of put together the pattern that we're going to use. Okay, so why don't you try this on your own? Go ahead and just pause the video and do the integral of 1 over x squared plus 4. All right, so hopefully you did this, and I'll work it out quickly, so hopefully we'll get the right thing. So this just becomes 1 over, I'll factor out a 4. I'm left with x squared over 4 plus a 1. Okay, so then I'll put the 1/4 in front, so 1/4 integral, and I can write that as x over 2 squared plus 1. Okay, and then I'll do the u sub here. So the u is just x over 2. The derivative of that is 1/2 dx, or dx over 2, it doesn't matter. So we put a 1/2 here, we balance the 2 in front. So this just becomes 2 times a 4th is 1/2 integral 1 over u squared plus 1 times du. Okay, and again we get to the same point. That's 1/2 inverse tangent of u plus c. So when I plug this little guy back in, we get 1/2 times inverse tangent of x over 2 plus c. Okay, so hopefully you recognize the pattern, right? We had a 4 here. We had a 25 here. And when you take the square root of those, we got, the 5s in our answer, the 1/5 x over 5. Square root of 4 is 2, so 1/2 x over 2. So the pattern that I was hoping you would come up with here is that if you integrate, for 1 over, if you integrate 1 over x squared plus k squared for some constant k, you get the inverse, forgot the constant in front, you get 1 over k times the inverse tangent of x over k. Now, if k squared is just some random number like 7, you might have a weird square root, but this is the general pattern that we're going to use going forward. Okay, so take note of that, and we'll bring that to the next video.